Hey everyone, good morning. Gonna get started. Quick show of hands. Who here thinks they don't work at a data company? Not a great question to ask at a data conference, I guess, to get the response I wanted. But the reality is every company runs on data, whether you're in retail, finance, healthcare, or logistics. Data powers the decisions, the customer experience, and increasingly the AIs that you're deploying. And while we love the idea that simply asking an AI, hey, refresh my data, and watching the results appear, the truth is a lot of moving parts have to work together under the hood to make that happen. In this talk, we're going to look at what really happens when you give that command, the infrastructure required, how LLMs interact with systems like Airbyte, and how to keep the whole process safe, reliable, and actually useful in production. By the end, you'll understand the gap between the ideal and the reality, the patterns that make it work, and why investing in the right data movement layer is key to staying relevant. I'm from Airbyte, the open standard for data movement used by 15% of Fortune 500 companies. We have 600 plus connectors. Airbyte moves data. David usually moves slides. And today, I'm the DR plan. Okay, seriously. All right, looks like we just failed over. I'm Ryan, your active presenter replica. David's primary is healthy, just geographically not available. I'm a solutions engineer, so I'll keep this practical. How teams actually make AI refresh my data work without paging security. We're envisioning a push-button world where you ask an LLM for fresh data, and bam, it's there. The reality is much more nuanced, though, especially around authentication, governance, and choosing the right tools to actually move the data. In an ideal scenario, your nervous system is perfect, intact, understood, authentication just works, the right slice of data is fetched, and trustworthy results come back securely with no drama. But in reality, it's a lot less magic and a lot more Kubernetes. Under the covers, we have a simple pattern. So we read from BigQuery and we write into Salesforce. Each is packaged as a connector that runs as containers. The important bit is the reliability, isolating each of those steps, observing it, and letting the pattern handle the lifecycle. Connectors need orchestration, so a scheduler is responsible for spinning them up, scaling parallel jobs, and retrying when things fail, all while keeping things and everything on time within quotas. Practically, it manages concurrency, backoff, and windows, so we don't overload sources or miss SLAs. And all of this has to be remembered somewhere, so your configs and your credentials are safely stored in the DB. Otherwise, someone, maybe the AI, will be reinventing the wheel every time. But here's the missing piece. How does the AI even know what it can do? It doesn't magically understand connectors and schedulers. Every runs need a configuration, a state, which is the cursor or the checkpoints, and credentials. We persist those centrally, so those jobs are reproducible and auditable, and we never re-ask for secrets in a chat. Only now with this mini architecture can we do what we set out to do 8 slides ago. Hey AI, refresh my Salesforce data. When you're really asking is to spin up connections, schedule jobs, retrieve configs and credentials, it's not exactly magical anymore. And this is where things get interesting. Because once the AI has a menu of actions, you have to make sure the menu never leaks the actual secret ingredients. You don't want people to know how your famous fish and chips are made. Similarly, privacy and security are big considerations using LLMs. The model can order use Salesforce connection number 123, but it never should see the Salesforce password itself. That's why you hear people talk about data locality or data sovereignty, which is all about controlling where the data lives and who can access the data. So now the AI has a menu, it understands all things it can do, that's great, but the first question we have to solve is, what's the safest way to let the AI order without giving away our secret sauce? And this is the edge case we absolutely cannot allow, pasting your Salesforce password directly into the chat. Think about what that means. Not only does the LLM see it, but so do logs, training data, fine-tuned derivatives. You've just taught your company secrets to an ecosystem you don't control. You can't put that toothpaste back in its tube. So what's the right mental model here? I actually think you can borrow from history. So in traditional programming, we solved a similar problem with pointers. Instead of passing the entire object in memory, you just pass a reference, and that way the real value lives where it belongs. It's the same here. The AI doesn't need the actual Salesforce password. It just needs a pointer. Use connection 123, the config, and the data plane handled the real secret. And while building MCP servers, we found that passing a 200-line YAML is a painful, lengthy process, but references are instant, and they must never touch an LLM. And this leads to an even bigger question. What does it mean to power AI? Here's an example of a safe flow. User stores their secrets in a secret manager. The LLM can see which secrets exist, but not their actual values. If one's missing, it can tell you what to add from the specification. So now your MCP tool is able to hydrate secrets at runtime, and the model never has creds. This makes for a happy security team. A lot of buzzwords. But unfortunately, those buzzwords don't run pipelines. Patterns do. And here's a compact framework that we use to route tasks to the right execution path. So we have these 4 quadrants that consist of ETL, ELT, so extracting and loading your data, reverse ELT for sending your data back to an API source. We have the get refresh, which is good when you don't want storage and you need freshness and latency matters. And then we have a put and post update for like incremental syncs for small amounts of data. And that's great for vendor APIs. And with these 4 quadrants, you can power all your use cases from structured and unstructured data, streaming and batch, agentic and humans, internal data and external data. And this is where the AI fits into this model. AI is the layer in which an MCP servers need so they can cut through the grid. They're just able to cut right through it, and they cut out all the extra steps that are involved. Good tools are also more important than smarter agents. Your agents will succeed when the tools are clear. So this is today's model, but AI raises the stakes because so much can go wrong. There's a lot of risks in the AI world, from secrets being placed in prompts, cascading refreshes, brittle model switching. The model needs to be kept sharp and like flashing warning lights and be extremely deliberate. All right, enough theory. Let's see it live. Okay. Give me a sec here. No. Sorry. Okay. Let's try it one more time. There we go. All right, well, it's not replicating my screen, so we will just do it on the screen itself. Let me try one more time. All right, there we go. Cool. Sorry about that. All right, so what we're going to do is we're going to talk to Claude. We're going to tell it to spin up a connection. We're going to hop into Airbyte Cloud right now. So we have all these workspaces that are available, and we're going to hop into the Big Data London MCP demo. As you can see, we don't have any connections set up. We don't have any sources. This is our catalog with 400 plus connectors. We don't have any destinations where we're going to send that data to. And we have Claude up and running. So we have an MCP server that is plugged into Claude. We have the secrets and all the configs stored in a file that is also loaded in that it can reference. So we're going to hop in. We're going to say, hey, Claude, can you help me set up a BigQuery source connection on Airbyte Cloud? Let's see what it does. All right, it's going to help me set up a BigQuery source connection. So it's checking Airbyte Cloud, make sure we have access to the workspace. We're successfully connected. I can see you're connected to Airbyte Cloud. So now it's going to check BigQuery source connectors are available and get information from the config. So it's getting the configuration from our API right now. And the API is loaded into that MCP server, all the calls I need to make for this. So it found the BigQuery source, and it's getting the detailed information about the connector. So it's getting all the required fields, all the optional fields. It's reading those from the secrets that I've given it. And now it's checking for any environmental variables that might be available. So as you can see here, it's finding my client ID, but it's not actually printing that or receiving it. It's seeing my client secret, but it's not actually seeing that secret. It's just giving it a reference, and it's seeing my workspace ID. So it sees the environmental variables, and it's going to try to create that connection now. So now it's deploying that source to my cloud environment. While that's going, we're going to hop over here into our sources. Looks like it finished, but it is hung up for some reason, doing LLM stuff. But it has created the source here with all the credentials that I've given it. All right, there it is. Great. Your BigQuery source has been successfully deployed. This is an error. I think these pop up because it was iterating through a couple of things. Maybe the API call wasn't correct, so that's okay. So it even gives me a preview of what the stream looks like. So what we have here is a user's table that it's able to see. Great. So now what we can do is we can create a source once it discovers the schema. Okay, so it's completed the source, successfully deployed BigQuery source. This is the source ID. We can click here, view it in cloud, and it found the user's stream, and then it found it has fields ID, name, and created at. All right, great. So now we're going to go and create a S3 destination. So Claude, please create an S3 destination on Airbyte Cloud with CSV formatting on US East 2, and no flattening and no compression. All right, so it's going to take care of that. I was going to not include that CSV formatting, the US East. It was going to tell me why I can't connect it. It's going to see that this bucket doesn't exist, that it's not on US East 2. I missed a dash. Let's see how the dash is in the wrong place. Let's see if it can figure that out. Probably should. So it's going to help me create that S3 destination. So now it's getting detailed information about the destination connector to understand the configuration options. Another error, probably likely from a malformed API call. All right, I found the destination S3 connector in our spec. Yep, notice I mentioned US East 2, but I'll use the correct region format. Thank you. Okay, I found my secrets. So it has the access key ID, the secrets access key, found the bucket name, the path, and the region that I gave it. It's sending it with CSV, no flattening, no compression. All right, great. So that's deployed now. We can hop into our cloud environment, go into destinations, and we see that destination is now available with all the configuration here. And lastly, what we're going to do is we're going to set a sync to run. So can you run a quick sync on this? Let's create the connection. Can you create a connection from BigQuery to S3 and run a quick sync? All right, so now it's going to join those together in a connection on cloud using the source ID, the destination ID, and it's going to use that stream it already discovered, which was users. Okay, so we have no connections at the moment. Let's give that a moment to run. My plan was to spin up a data plane on my laptop, and we were going to use that to deploy the source and connection, connect that to cloud. I think we were going to run out of little time, so skip that step, but that is functionality that's available. So we can spin up a data plane in any region, locally on an EC2 instance, and connect that with our cloud environment. Or if we're on self-managed enterprise, we can deploy data planes in any region, spin those up, and make the connection. So our connection's been created, and now it's running that sync. So let's hop into the connections. Here we go. We got our BigQuery source, S3 destination. It's running as of 23 seconds ago. And it's syncing that user stream right here. Let me zoom in a little bit. All right, great. So that should take about a minute to run. I think it's going to wait, make sure it's finished, and then it'll update us. Okay, so it's discovered the schema. It just finished. It brought in 10 records. Great. So now it's going to check the logs, give us some details about that. So it's going to parse those logs. It's going to tell us how many records we brought in, what the schema was likely. So it's, let's see here, get the cloud sync status, connection ID. Okay, great. We got a response back. Connection name, connection ID, gives us a link to the cloud environment. It's a successful sync with 10 records synced, 590 bytes. And we can take a look at the timeline. So BigQuery user table brought in the 10 records. And we can go in and delete that connection. We can set up a sync frequency now at this point and modify any of the connection settings from here. We can set some mappers up. So if we want to do some encryption or some hashing on fields, we could tell it to hash out the name maybe, and it'll do that and send it to S3 as a hashed variable. All right, great. So let me hop back over. All right, so I'll just finish up here. So takeaways, we need a unified model to handle this. The principles of normal data engineering, which we're not passing secrets directly in chat, we're passing them through an LLM, and we have practical patterns that can handle this. We consider this nothing fancy, just the framework we need to pull this data in safely with an LLM. So thanks a lot, everybody, for your time. We can start a Q&A now with how much time we have left. Any questions? Yeah.
What is the process to publish connectors?
Yeah, so there's a couple ways to publish connectors. So you can, we have a low code framework. You can make a YAML. You can pass that YAML in a Terraform code to create the source and publish a connector at the same time. You can publish it locally to your workspace. with Docker, if you're on a self-managed or an open source environment, we don't allow like custom Python in cloud, so you have to create it with our low-code connector builder in that case, which allows you to connect to most like 90% of APIs successfully. And it's kind of like a Postman interface, but also you can use a low-code YAML to set that up. Yep. Any other questions? Yeah. Yeah, thank you.
Is there a way to work with AI agent for Airbyte, but like open source Airbyte, or it's only for Airbyte on cloud?
Sorry, I had trouble hearing you.
So you were showing us how can we work with Airbyte using AI agent
Right.
like Claude, for example. Is there a way to do this, but with the open source version of Airbyte,
Yeah,
or
not
only
at
the
the
hosted one?
not at the moment. We're still in the development phase. We're partnering up with some of our customers to build this, but stay tuned. Hopefully we can make this available to everybody soon. Yeah, right over here. Thank you.
So, how does a sync connect with Airflow? And if a sync fails,
Yeah.
will the failure log be pushed to Airflow?
Sure. Yeah. So Airflow can be connected to Airbyte because we have an API. So basically, you set up your syncs with your orchestration with Airflow, sending those API calls to Airbyte. That could be programmatically set up. Error logs, we send notification emails and webhooks. So those can be sent to a Slack, to a Teams channel, or to your email. But we do just send that there is a failure to Airflow. We don't send the detailed logs to Airflow. Thank you. Any other questions? All right. All right, thanks a lot, everyone. Our booth is down over that way, so come on by and say hi. Thanks a lot for joining. Appreciate it.